Hi everyone. In this video, I'm going to discuss setting up equations. First, I'm going to look at setting up equations from relationships described in words. And next, I'll look at setting up equations from relationships described in a table. This is the second video in the series on grade 8 equations. In the first video in the series, we described an equation as a statement where the values of two mathematical expressions are equal. Now, what is the difference between an expression and an equation? An expression is just a mathematical sentence, whereas an equation has an equal sign. It has two parts equal to each other. So below the definition, I have two examples. The first example says 5 multiplied by a number is increased by 4. So let's let it be x. Because I don't know what the number is, so I'll choose a variable because the value of the number could vary. So 5 multiplied by the number, 5 times by x, or 5x, is increased by 4. Now that there is an expression. Now the sentence below it describes an equation. As you can see, this first part is exactly the same. It says 5 multiplied by a number increased by 4. So we know that it's 5x plus 4. But at the end it says is 64. So I will say that is equal to 64. So now I have two expressions equal to each other. So this here is an equation. Here I have a list of descriptions. What I'd like for you to do is to pause the video and try to translate these descriptions from words into algebra. Some of these descriptions are expressions, and some of them are equations. All of these descriptions relate to values where you don't know what the number is. So in these situations, use variables, x or y or z, or any variable you choose to represent the number. So pause the video now to try these questions. Here are my translations of the descriptions. The first one says the sum of two different numbers. So I'm going to make my numbers x and y. So the sum of two different numbers will be x plus y. And as you can see, this is an expression. The next one says the sum of two different numbers is 20. So the sum of two different numbers, I'll use x and y again, is equal to 20, and I can see that is an equation. Now you might have chosen different variables than I did to describe these situations. However, if your structure is the same as mine, you will be correct. The next situation says the product of two numbers. So again, let me make my two numbers x and y. So the product will be x times y, or a shorter way to write that is xy. Now that, again, is an expression. The next description says the product of two numbers is double another number. So let's make this other number z. So the product of two numbers, xy, is double 2 times z. That is also an equation. The second last sentence says the number is a third of another number. So let's make my first number x and my other number y. So the number is a third of y. Or another way to describe that would be a number is y divided by 3. Both of those would be correct. And again, these are equations. My last description is the cube of a number. So the cube of a number, let's use x for the number. If I want to find the cube of that, I'm going to say x cubed. And that again is an expression. Here I have some more relationships described in sentences. Again, I'd like for you to stop the video, try them yourself, and when you're done, start the video again. So let's look at the answers. The difference between A and B is 5, where A is larger than B. So if A is larger than B, if I want to work out the difference, I'm going to say A minus B, and the answer is 5. The next sentence says, when C is divided by D, the result is E. Now in algebra, we show division as a fraction. C divided by D is E. It wouldn't be incorrect if you said C divided by D is E, but the convention is normally to write division in algebra as a fraction. The next sentence says, the square of m plus the square of n is the square root of p. So the square of m, m squared, plus the square of n, n squared, is the square root of p. Note that this is very different to m plus n all squared. That's not what I'm doing. I'm squaring m and squaring n and adding them together. The next sentence says, if the sum of q and r is doubled, the answer is 25. So I'm going to add q and r together, and I'm going to double that. So I'm going to multiply it by 2. Now a nice way to show that is actually to put the 2 in front, and I get 25. You could have written it like this, q plus r times 2 is 25, and that would also have been correct. But what's very, very important is that you need to have the brackets, showing that you first add q and r, and then double that answer. The next question is slightly different. It says double q and add p. So here I'm saying 2q and then adding only 1p, and the answer is 25. Do you see the difference between the two questions? The one before says double the sum of q and r, so I first add q and r together, and I show that in a bracket. And the next question, I'm only doubling q, so I don't need a bracket because only q is doubled. The last sentence says half the sum of x and y is equal to 48. So first I'm going to add x and y, and I'm going to halve that, or another way to halve something is dividing it by 2. And that is equal to 48. You could have also written this as half of x plus y is 48, or x plus y divided by 2 is 48. Those would also be fine. But according to algebraic conventions, it's best to write it as a fraction. Now let's look at an equation from a context. Having an equation in a context can help you to calculate something quickly. The situation is a plumber charges 600 Rand call-out fee and an additional 350 Rand per hour for any work done. Again, I'd like you to pause the video, try these questions, and then unpause the video and see if you got the same answers as I did. So here are the answers. The first question says, create an equation that you can use to calculate what the builder charges for the job. So let's say that C is the cost of the job, and let's use H for hours worked. Now you might have chosen different variables. The variables you choose doesn't matter. The equation I would have is the cost is 600 Rand, which is charged no matter what, plus 350 Rand times by the number of hours worked, so 350H. The next question says, how much will the plumber charge for 5 hours of work? Now we know that the plumber charges 600 Rand for coming out as a call-out fee, and then 5 hours of work. on top of that. So we're going to use my formula that I have, 600 plus 350, and this time my hours are 5 instead of 8. And so when I work that out, I get 2,350 Rand. The last question says, you receive a bill for 1,650 Rand. How many hours did the plumber work for? So this here is the cost, but we don't know how many hours the plumber worked. So if I was to put that in my equation, I'd have 1,650 Rand is equal to 600 Rand plus 350 Rand times by the hours. Now, as we continue our course on equations, you will learn different strategies for solving this equation and finding out what H is. Now, I'm not sure what strategy you used, but when I calculated what H is, I got that H was 3. That means the plumber worked for 3 hours. Each of these tables describes a relationship between two variables. What I'd like for you to do again is to pause the video, try and write an equation for each of the relationships, and then stop the video and see if you are on the right track. Let's look at the first table. If I compare the values between x and y, in each case it seems that my top value is multiplied by 3. 200 times 3 is 600. 50 times 3 is 150. 30 times 3 is 90. And 25 times 3 is 75. So surely to get from x to y, I'm timesing by 3. So my equation will be y is equal to 3 times x. It would also be correct if you said x is equal to a third of y. In the next table, going from P to Q, in the first one, it seems that I'm dividing by not 2, but negative 2. 10 divided by negative 2. 11 divided by negative 2 is 5.5. 12 divided by negative 2 is 6. So surely P divided by negative 2 is going to be Q. So Q is equal to P out of negative 2. Or another way you could describe it would be P is equal to negative 2Q. In the last table, when I look down, I don't have a simple way to see a multiplication or division or square from the top to the bottom, or from the bottom to the top. So let's look across. If I go from 0 to 1, I add 1. From 1 to 2, I add 1. From 2 to 3, I add 1. In the bottom row, from 5 to 8, I add 3. From 8 to 11, I add 3. And from 11 to 14, I add 3. So at this point, you should know that my equation has some idea of multiplying by 3, because repeated addition will be multiplication. So m is 3n. So if I think about each value, 3 times 0 plus how much? Plus 5 gets me to 5. Let's see if that equation works. 3 times 1 plus 5 is 8. Yes, it works. Let's try the next one. 3 times 2 plus 5 is going to be 11. So it seems that my equation does work. That brings me to the end of this video about setting up equations. I'm sure you'll notice that writing an equation is a far shorter way of describing a relationship than writing out the relationship in words or in a table. And as you develop in your maths, you'll realize how powerful it is to work with equations instead of writing out long descriptions of situations.